Hey guys, Mr. Yisley here. So we're going to move on to our graphing of linear inequality examples. So as we talked about in those examples, the graphing portion is really the same for creating our line, with one small exception of if it's a dashed versus a solid line. So the first thing we want to do always is we're going to start with our y-intercept, and our y-intercept is found after x. So that would be our -2 here. So 0, -2 is our y-intercept, which is the exact same as linear equations. That's no different than what we had before. So we're going to start by graphing that point. So from the origin, go down 1, 2, and there is my y-intercept, the point where it's going to cross the y-axis. Second thing we want to do is we want to use the slope, right, to determine our next 2 points. So slope, well, our slope again is always found in front of the x, so that would be this 1/3. So 1/3 is our slope. So we need to determine what does each number of that tell me to do. Well, top is always rise or fall. Well, it's a +1, so that tells me I'm going to rise 1 because positive numbers tell us to go up. The bottom is a positive number as well, so that's going to tell me to move to the right 3. So there is our movements to create our next 2 points. So we need to go to our y-intercept. The first thing we do is rise 1 and then move to the right 1, 2, 3. And there is my next point. Then I need to do it again. I need to go up 1 and to the right 1, 2, 3. And there is my next point. So again, we need to create a minimum of 3 points. If you wanted more than that, that's fine. Also remember, you can do the exact opposite of both movements with slope. So instead of rising 1, I could fall 1, and instead of moving to the right 3, I could also move to the left 3, and that also will create a point on the line. So once I've got my points graphed, before I draw my line, the next thing that I need to do is I need to check my inequality symbol, because this is going to tell me if I have a dashed or solid line. So when I look at this inequality symbol right here, the first thing I want to determine is, does it have a portion of an equals to sign? This one does not. And so what that means is that this is a dashed line. And dashed lines mean that all the points on the line are not solutions to the problem. All right? So we represent that by creating a dashed line. So when we go in here, we want to make sure that our line ends up looking like a dash, a bunch of dashes connected with arrows at each end. Right? And we want to be precise as possible, so I'm going to draw my line as best I can. There's a few ways you could go about doing that. Right? You could create the dashes just like I did as I went. Right? You could also draw a line and then go back and erase portions to make it into a dashed line. I don't really care which way you do that, just make sure that it's a dashed line if it's supposed to be a dashed line. Now the next point, after we've got our line drawn, and this one's a dashed line, looks like that, right? The next thing we want to do is a test point, right? And we want to use a point on the graph that is not on our line. Well, again, our recommended point is 0, 0, the origin, right? Which is not on my line, so it happens to be above my line. So I'm going to use the test point 0, 0. And what I'm going to do is I'm going to plug that back into my original inequality, because remember, these are x and y values. So n for y is going to go 0, which is less than 1/3 times n for x is going to go 0, and then -2. So all I did was plug the x and y coordinates in for the x and y. And then after we've done that, what we're going to do is simplify that down to see if it makes the inequality true. So is 0, 0 an actual solution to this? Now the reason I recommend 0, 0 is because anytime you plug 0 in for x, right, whatever your slope is, when you multiply 0 by anything, it's still 0. So really this just cancels, and we're left with whatever else is on the right side. So what I'm left with is 0 is less than -2. Again, the reason that this cancels is 1/3 times 0 is 0, and 0 minus 2 is -2. So it's always going to cancel if we're able to use the point 0, 0. So 0 is less than negative 2 is what we ended up with on our simplified inequality. Now what we need to decide is that true? Is 0 less than negative 2? Well, no, 0 is not less than negative 2, which is false, which means everything on the side of the graph or the side of the line where the test point lies is going to be false. So everything on that side is false. Well, that means that everything on the opposite side of the line, so in this case, this side, would be true. And the true side is where all of our solutions end up, right? This is where they're all going to fall. So in order to show that, what we do is we shade that side of the graph. So everything on this side is a solution, and in order to show that, we shade that side of the graph. And there we go. This is how we represent the solutions to a linear inequality through a graph. All right, well, I'd encourage you to try example B on your own, then check your answer with mine. So y is greater than or equal to negative 2x. So first thing we want to do is start with our y-intercept. And y-intercept is always found after x. Well, when I look at this, I don't see anything after x, which really means, as we've talked about before, that this is like plus 0. So my y-intercept is 0. So I'm going to go in and graph that point. So 0, 0, my y-intercept is 0, 0, because the x-coordinate is always 0 on a y-intercept, and the y-coordinate on this one happens to be 0. So 0, 0, the origin, that is my y-intercept of this equation. Then I need to use my slope, which is always found in front of x. So that would be negative 2. So my slope is negative 2, but we need that in fraction form in order to be able to use it. Right? So I need to put that over 1. So it's really negative 2 over 1. Then we need to decide what each number tells us to do. Well, on the top, we're either going to rise or fall. Well, negative tells me to fall, so I'm going to fall 2 from my y-intercept. Then I have a positive 1 on the bottom, so that tells me to move right 1. So there are my movements, so now I need to create my next 2 points. So from the y-intercept, I'm going to fall 1, 2, and then move to the right 1. Again, I'm going to do it, fall 1, 2, then move to the right 1. Now again, reminder, you could always do the opposite of that as well. All right, we could rise to 1, 2 and move to the left 1, and that is still a point on the line. Now before I go in and draw my line with my ruler, the next thing I need to do is look at my inequality symbol. And if there is any portion of an equals to sign, that means that we have a solid line. So when I look at this, it is greater than or equal to, so it does have a portion of an equals to sign, which means this is a solid line when I draw it. So again, I'm going to line up my points as best possible with my ruler and then draw my line. And this time it is solid. So, and don't forget, all the way across your graph with arrows at each end. Now we've been talking about the importance of going all the way across the graph, and it becomes even more important with linear inequalities because we're going to shade one side of the graph. Now the next thing we need to do once we've got our line graphed is we need to figure out a test point. Now before, in our recommended test point was 0, 0, but that falls on the line. And with solid lines, our points on the line are always solutions. So by plugging 0, 0 in, all I'm going to know is what's on the line is a solution. Well, I already know that for this inequality because it's a solid line, so I need to find a point that is not on the line. So I'm going to use the point 1, 1. Now again, you could use any point that's not on the line. I'm choosing to use the test point of 1, 1. So I'm going to write that up there. Then I'm going to plug those numbers in for the x and for the y. So in for y goes 1, which is greater than or equal to negative 2 times x, which again is 1. And then the plus 0, I'm not even going to write that because it wasn't even a part of my original inequality. So the next thing I need to do is simplify down. So I've got negative 2 times 1, which is negative 2. So I've got 1 is greater than or equal to negative 2. So I've simplified it down to the two numbers, so now I need to decide, is it true? Is 1 greater than or equal to -2? Yes, 1 is greater than -2, so this is true, which means everything on the side that the test point was on is also going to be true. They are all solutions, which means everything on the opposite side is false. And if you notice, I write T and F to remind myself when I go to shade which side I'm supposed to shade. Because all the solutions are always going to lie on the true side, we always shade the side with the T. So here we go. I'm going to shade this side, and that shows where all the points lie that are solutions to this inequality on that side of the line. Now again, with solid lines, points on the line are also solutions to the inequality. All right, so the solutions on the line as well as to the right or above this line, all right, are solutions. Everything to the other side of the line are not solutions. All right, well, let's move on to example C. And example C and example D are kind of the special case ones. They work really similar to what our linear equation special case ones are, all right? What we have to remember is what those lines look like based on what the inequality looks like or what the equation looked like back in that point. So example C says y is greater than 4. So the first thing we need to do, all right, is we need to find the y-intercept, which is always after x. Well, there is no x listed, all right? Now, because there's no x listed, all right, we know that that means it's one of those special ones. And there's only one thing that could make the x go away, because slope in front of x is multiplying it. So there's only one number that would make x disappear, which is 0. I can multiply x by 0 and it would become 0. So really, this on example C, and let me move this up before we start writing. On example C, what we have is y is greater than 0x, and then this is a positive 4. Now, if rewriting it helps you, I would encourage you to do that. So again, start with my y-intercept, which in this case is 4, and I graph that point. So y-intercept of 0, 4. And I'm going to graph it. So don't move left to right, but move up 1, 2, 3, 4. And there is my y-intercept where it's going to cross the y-axis. Then I need to use the slope. Well, again, there's no x listed, but when we rewrote it, we remembered that 0 multiplying x made it go away. So the slope is 0. Well, we have to remember 0 slope lines are very specific in how they look. And we've talked about this before. It's kind of like one of those machines at the hospital that measures heartbeat, right, or heart rate. We've got, when we have a completely no heartbeat, we're no longer alive, all right, our heart's no longer beating, it makes that flat line, right? So 0 slope, 0 heartbeat, flat line. So we're going to end up with a completely horizontal line as we've been talking about. So I need to just draw 2 points. Either I could do 2 to the right, 2 to the left, 1 on each side, but just make sure I've got my 3 points just so I can get a nice straight line. Now before I graph the line, I still, even though it's a special case one, have to go back to the inequality symbol. And I have to say, all right, is there a portion of an equals to sign here? Well, no, there's not. So that means that this is a dashed line. So even though it's one of the special case one, it still follows the rules with linear inequalities about dashed and solid lines. So what I'm going to do is I'm going to go in and draw this, and I want it to be a dashed line. So I'm going to go in and to draw, to the best of my ability, a dashed line. And remember that we still need to have arrows at each end. So again, you can dash it as you go. You can draw a solid line and then go back and erase portions, whatever works best for you, but make sure that you end up with a dashed line when you're supposed to have one. So then our next thing that we want to do is we want to plug in a test point, just like before. So I'm going to use the test point over here of 0, 0, which is below the line, right? And I'm going to plug that in. Because remember, our test points cannot go in, or cannot be on the line. So 0, 0, it's below the line. I'm going to plug that in to see if the solutions are below the line. So I'm going to plug into our original equation of y is greater than 4. So in for y goes 0, which is greater than 4. Now you may say, well, you didn't plug in an x. Well, there was no x in the equation to plug into, or in the inequality, excuse me. So I don't need to plug it in, and that's okay, right? I could plug it into the one that I rewrote, but I'd still end up with 0 there, so we'd still end up with positive 4. So I'm just kind of making my life a little easier by plugging into the original inequality, and the only thing I had to plug in for was the y. So I ended up with 0 is greater than 4. I need to decide if that's true. 0 is not greater than 4, so that's false. So everything on the side of the line where the test point was would be false, which means everything on the opposite side would be true. So all the solutions always lie on the true side, so I need to shade above my line. All right. So in terms of work that you would need to see, and I've shown a lot of stuff on here, the big things, one, make sure you've got your line graphed appropriately, all right, dashed versus solid, all right, make sure you've shaded the appropriate side. I would encourage you to write the T or the F, though I don't require it, right, but you do need to show your test point. Both what did you plug in, and when you plugged it in, how did you get it simplified down like we did on A and B, or on these other ones, it's pretty simple, it just became 0 is greater than 4. Then we decided from there. So that's the work we need to see. All right, so last example here is example D. All right, make sure you put a star on this one. All right, it's another special case, but this one's a lot different. Right, you may already be looking at it and noticing it, and you may even remember this one from the linear equations, how it works. But when we have x is less than or equal to -1, this is that special one where we don't have a y. Right? And when we don't have a y, these lines always look the same, right? They're always going to be perfectly vertical lines, right? When there's no y involved, the only thing we really know is that x is going to deal with that number, right? That's across from it. And we've been talking about this in class. Did it in some other lessons with linear equations. So it's one of those things we just have to remind ourselves of. So in this one, I have x is less than or equal to -1. So the only thing I really know about this is that -1. So I'm going to go where x is -1, and I'm going to put a point. So that's just to the left of the y-axis. So there is that point. Now remember, these lines are always perfectly vertical. So we're going to end up with points either above or below or both. So I'm going to put a point above and a point below, because it's going to be a perfect vertical line. Because remember, with these, we can't find a y-intercept because they don't have one, right? And we can't find the slope because it doesn't have a slope. It's an undefined slope because the x is not in its normal place and there is no y. We can't use our normal method. So it's one of those ones we just have to remember. But these do follow the same rules, though, about the inequality symbol. So before I draw the line, I need to look at my inequality symbol, which in this case is less than or equal to. Now when I look at that, right, I say, does it have a portion of an equals to sign? Yes, it does, so that means it is a solid line. So I'm going to draw a perfectly straight up and down solid line because it has a portion of an equals to sign. So I'm going to go in and draw my line. So there we go, arrows at each end. And again, make sure it goes all the way across your graph. Now from here, I still want to follow my normal rules about a test point. So I'm going to pick a point that does not fall on the line. In this case, 0, 0 doesn't fall on the line, so I'm going to use that. So I'm going to plug the test point of 0, 0 into my inequality. So in for the x goes the 0, that x stands for, which is less than or equal to -1. Now, is 0 less than or equal to -1? No, it's not. So that would be false. Right? Now you may be saying again, you didn't plug in a y. Well, again, I don't have a y in here, so I can't plug this in. So this part really doesn't matter, just like the x on this part really didn't matter. We only plugged in for the variable that we had. Now again, that was false, so that means everything on the side of the test point that's on the same side as the test point, which was right here, is going to be false, which means everything on this side is going to be true. And we always shade the side that's true. So we're going to come over here, and we are going to shade this side. And we're going to do our best. It doesn't have to be perfectly solid, but it needs to butt up to the line, and it needs to show that everything on that side is a solution. All right, well, that's how we graph them. I know this was a longer video, but just hopefully gives you what you need to continue on in the notes and what you need for your assignment.